Hello all. So today we are finishing up chapter 6 and we're talking more along the lines of biomechanical analysis. This is part 4. Various instruments and techniques are used by biomechanists to study and analyze motion. During the past 15 years, improvements in instrumentation coupled with advances in computers and microchip technology have greatly assisted biomechanists in their endeavors. Additionally, the development of better and more creative methods of using these instruments has greatly enhanced the understanding of human movement and the ability to improve performance. These tools include computers, anthropometry, timing devices, motion capture, videography, electrogoniometry, electromyography, dynamography, and telemetry. Sometimes researchers use wind tunnels. These tools, as well as visual observation, can be used to perform quantitative and qualitative analysis of human movement. Computers play an important role in biomechanical research. Biomechanical analysis requires dealing with prodigious amounts of data. The use of computers in dealing with such data is a necessity. Additionally, much of the instrumentation used in biomechanical research is linked to a computer. Much of the analysis of information can be performed online so that the results can be available almost instantly. Computers can also be used to simulate movements. Simulation requires the use of mathematical formulas to develop models of a specific movement. Then, this computer model can be used to assist biomechanists in determining the effects of certain modifications in the movement or certain variables on performance. For example, simulation can address such questions as what is the effect of altering the takeoff position of a dive on the subsequent performance, or how does air resistance affect a skier's performance? This approach helps researchers determine how a performance can be improved. Comparisons of the optimal or ideal performance and an individual's actual performance are enhanced through the use of computer technology. The computer is used to generate graphic representations of the ideal performance and the actual performance. The drawing of the actual performance is compiled from analysis of the films of the performer. These graphic representations of the ideal performance and an individual's actual performance can then be compared. This helps to detect errors and identify strategies to improve performance. Computers offer biomechanists tremendous assistance in understanding human movements. Motion capture and high-speed imaging are two of the basic tools employed in biomechanical research. Sophisticated cameras are used to capture an individual's performance on a computer. These high-speed cameras capture details of movements that may escape the unaided eye of the professional observing the performer's movements. It is possible to measure such things as speed, angle, range, and sequence of moving segments. Motion capture provides graphic representations of the movement which can be completed in real time while the performance is taking place, or post-capture via computer processing. Completion of mathematical calculations based on information provided by the computer model is an essential part of movement analysis. This process is greatly speeded and simplified through the use of computers. Motion capture is used not only for biomechanical analysis, but also by the motion picture and video game industries for computer animation. High-speed imaging utilizes sophisticated cameras to capture performances either on digital media such as memory cards and sticks, or directly to a computer via Wi-Fi or Bluetooth. Immediate feedback is available to the performer, coach, or practitioner via a computer or mobile device with slow motion and stop action capabilities to aid in the study of the performance. Many software applications allow stop action sequences of movements to be displayed. This enables sequential pictures of key body positions to be seen at once. For example, the path of the various body segments of a forehand stroke in tennis can be displayed to analyze the player's execution of the stroke. This facilitates the analysis of the individual's movements. With this technique, one person's execution of a movement skill, the forehand tennis stroke or the wrist action used, can be compared with that of another person or the ideal performance. Videography is the use of video devices to record an individual's performance. Almost all video equipment is digital, which greatly eases the use of video for performance evaluation. Unlike motion capture systems, video is relatively inexpensive, easy to use, and readily available to practitioners. With today's technology, most mobile devices have video cameras that are sufficient for analyzing many human movements. In the cases of fast-moving skills where high frame rates are important, practitioners may want to purchase a high-speed video camera, although some smartphones currently come with a high-speed video option. The ability to directly play back what has been recorded allows for immediate viewing by the analyst and prompt feedback to the performer. This is one of the most inexpensive high-technology systems for the analysis of movement. Advances in technology have led to better quality cameras, sophisticated playback capabilities that yield greater clarity of still and stop-action images, and user-friendly software applications for simple and inexpensive video analysis of human movement. Many mobile devices have cameras that can be used for video playback and analysis with applications available in every price range, and with features ranging from simple frame-by-frame playback to angle and velocity measurements. Anthropometry is concerned with the measurement of the human body. The length, width, diameter, circumference, which is the girth and surface area of the body, and its segments are measured. Correct identification of anatomical landmarks is crucial to obtaining accurate measurements. Information about the structure of the human body is used to calculate the forces acting on the joints of an individual's body and is important in the developing computer models of performance. Timing devices or chronoscopes are used to record speeds of body movements. Some types of timing devices are stopwatches, digital timers, counters, switch mats, photoelectric cells, and real-time computer clocks. The chronoscope is started at a pre-selected point in time, typically the initiation of a movement, and then stopped at a pre-selected time, such as the completion of movement. The speed of movement is then calculated. Radar guns can also be used to provide instantaneous information about speed. Some timing systems can be used for agility training and testing and can be programmed to measure an athlete's reaction to visual or audio cues. Many timing systems are fully integrated with mobile technology, allowing for easy storage and tracking of athlete performances. Electrogoniometry is a technique that can be used to provide information about the angles of the joint as part of a total motion pattern. Another term for electrogoniometer is elgon. An elgon works like a goniometer, but uses electrical devices such as potentiometers to measure the degrees of movement at a joint. This information can be transferred directly to a computer, recording paper, or oscilloscope. For example, this instrument would permit the study of the knee joint action when a particular skill such as walking or running is executed. It can also measure range of motion, angular velocity, and acceleration. Electrogoniometry may be particularly useful when combined with electromyography. Electromyography, or EMG, is used to measure the electrical activity produced by a muscle or muscle group. When properly processed, this measurement serves as an approximate indicator of the amount of force being developed by a muscle. This provides a means to provide the movement of a particular muscle or muscle group, or fine wire electrodes are inserted into the muscle to be observed. Electrical impulses from muscle activity are then processed, recorded, and displayed. EMG may be used in conjunction with electrogoniometry. The electroencephalograph, or EEG, provides the researcher with information how the brain influences motor activity, which is studied within the realm of motor control. Dynamography is a technique used to measure force, torque, or power produced during a movement. Isokinetic dynamometers are used to measure joint torque and power output in research and clinical settings. Strain gauges, load cells, piezoelectric, and other devices have been incorporated into equipment such as athletic footwear, insoles, bicycle pedals, and uneven parallel bars to measure the force produced by the performance using this equipment. Power meters are now available for cyclists and runners to monitor power output over the course of a ride or run. Another device that is used to measure force is the force platform. Force platforms can be built into the floor to measure forces such as those associated with a foot striking the floor during walking. They can also be designed to measure force production by athletes during sprint starts, pole vaulting, and gymnastics. Telemetry involves the wireless recording of various aspects of movement. Almost all mobile devices come standard with Bluetooth and Wi-Fi forms of telemetry and allow data to be sent from one device to another without wires or cables. Telemetry systems can be used to transmit information about heart rate or joint angles, which is electrogoniometry, during a performance. A distinct advantage of this technique is that it permits movement data to be recorded without encumbering the performer with wires and other equipment that can hinder performance. Some companies are making data logging systems that enable data from sensors to be stored on memory cards used in small data recording and storage units worn by the performer. Telemetry and data logging technology has greatly increased the mobility of performers during data collection, as well as the number of activities that can be studied. Wearable technologies include accelerometers, GPS or heart rate monitors, temperature sensors, and much more, increasingly available to provide real-time feedback to mobile devices, allowing coaches and athletes to monitor many aspects of performance. Quantitative and qualitative methods can be used to analyze human movement. Quantitative analysis uses many of the techniques described previously to provide specific numerical information about the movement being studied. Specific information, for example, about the joint angles during movement, the force generated, and the speed of movement. Quantitative analysis are used predominantly in research efforts and are increasingly incorporated in clinical diagnosis, treatment, and rehabilitation, and as part of the overall training program of elite athletes to help them optimize their performance, such as biomechanics working with elite athletes at the U.S. Olympic Training Center in Colorado Springs, Colorado. With advances in technology, quantitative analysis of performance are becoming more readily available to recreational athletes via sports medicine clinics, sports performance and fitness facilities, and even wearable technology. Qualitative analysis also provides important information about the movement being studied. Qualitative analysis relies commonly on visual evaluation of the movement. Hall emphasizes that qualitative analysis is not limited to generalized statements about performance, such as whether it was successful or not. Hall stated that qualitative analysis can provide rich detail about the performer's movements, such as the release of the ball did not take place at the optimal angle. An individual's performance also can be compared with another individual's performance or against a standardized model. Qualitative analysis is most commonly used by practitioners. It offers practitioners who may not have access to sophisticated equipment or have the background to employ advanced techniques a method to effectively analyze an individual's movements. Biomechanical analysis can be used by athletic trainers in designing a rehabilitation program, by physical educators and conducting an evaluation of fundamental motor skills, and by exercise leaders in ensuring that clients perform each exercise correctly. Teachers and coaches can use biomechanical analysis to improve students' and athletes' performance of sports skills. Additionally, teachers and coaches are often faced with the task of evaluating several performers of diverse skill levels in a short period of time. The use of video in slow motion or stop-action playback can be useful to the practitioner in assessing an individual's performance. Mobile devices, such as smartphones and tablets, and the many applications available for them, may have made video analysis increasingly available to professionals. Inexpensive apps for these devices, like Coach's Eye, let professionals create videos and analyze the performance of their program's participants. The video can be played back slow motion and annotated, identifying areas where improvements can be made. Videos can be compared side by side, comments recorded and both shared with the participants. Coach's Eye and other apps make video analysis of performance, whether in classes, during practices, or when working out, much easier than in the past and much more affordable. Technology will continue to drive the advancement of knowledge. Adrian and Cooper state, with today's sophisticated technology, we have been able to learn more about human movement in the past 10 years than in any previous decade. To answer further questions, Adrian and Cooper assert that we must use basic concepts about what is known to pose the questions of the future and create more effective, safe, and rewarding human movement. Adrian and Cooper state that mathematical modeling of the anatomical characteristics of individuals, coupled with computer simulation techniques, enables biomechanics to make predictions of performance as well as to develop new and advanced performance techniques. Expertise in mathematics and anatomy, physiology, physics, and computers is necessary to take advantage of these approaches. Data collected via the tools of motion capture, high-speed imaging, dynamography, electrogoniometry, electromyography, and accelerometry form the foundation for modeling and are entered into the computer, which analyzes the data using various software packages. Simulations allow movements to be varied with respect to speed, timing, range of motion, and environment. Through simulations, these changes in movement variables can be explored, and determinations can be made about the optimization of performance and its safety. Computer-assisted drawing, design programs, and 3D printing can expedite the design of equipment. Advances in the analysis of human movement continue to be made at a rapid pace. The increased availability of technology at a decreased cost has made sophisticated analysis readily available to teachers, coaches, athletic trainers, athletes, fitness participants, and practitioners. The use of multidisciplinary teams composed of sports scientists from the various disciplines facilitates the integration of data from multiple sources, enhancing our comprehension and enabling physical education and sport professionals to work more effectively with students, athletes, and individuals of all ages, seeking to move more efficiently and effectively. The integration of biomechanics with motor development can increase our understanding of movement across the lifespan and enable us to more readily design solutions to remedy problems and safely advance the motor performance of people of all ages and abilities. Expert profiling and simulations advance the frontier of knowledge and lead to improvements in performance. Throughout the world, these databases allow for diagnosis of movement problems, profiling, and collaborative research ventures. The World Wide Web offers a wealth of information to individuals interested in biomechanics. The International Society of Biomechanics offers links to profile of different biomechanists, laboratories worldwide, and even a place to trade or sell equipment. Specialized areas of study are represented, including gait and locomotion, sport and exercise biomechanics, muscle and motor control, computer simulations, ergonomics, orthopedics, prosthetics, and biomedical engineering. Also included on the site is information on biomechanics societies, career opportunities, and professional journals. This site and other related sites offer access to current information and a venue to share ideas and stimulate collaborative endeavors. Just a few talking points. Concepts such as force and power or jumping ability are sometimes racially stigmatized. The stigmatization needs to be eliminated in sport. The potential for biomechanics to create the means for individuals with physical disabilities, amputations, or spinal cord injuries to participate in physical activity in sport is huge and warrants greater attention from professionals. The potential for biomechanics to create the means for individuals with physical disabilities, amputations, or spinal cords to participate in physical activity in sport is huge and warrants greater attention from professionals. Advances in computers and instrumentation, as well as the manner in which they are used, have contributed much to the understanding of human movement. For example, the intersection of biomechanics and biofeedback has stimulated the development of new devices to improve sport. Biofeedback is the provision of information about a physiological or biomechanical parameter, such as heart rate or acceleration, to an individual. The individual then uses that information to modify his or her response. Wearable technologies, such as those by Fitbit, Apple, Garmin, Polar, and Jawbone, all provide biofeedback to athletes. Further advances in smart apps, wearable devices, and clothing and video technology will enable individuals as well as professionals to move quickly and easily analyze the performance. The growth of 3D printing technology will enable individuals to design shoes, equipment, and wearable technology to fit their specific individual characteristics and needs. Biomechanists will increasingly work as part of multidisciplinary teams with other sports scientists to enhance the movement of people of all ages. And in summary, understanding the factors that govern human movement is essential for physical education, exercise science, and sport professionals. Physical education, exercise science, and sport professionals are concerned with helping individuals optimize their movements. To accomplish this task, they need to thoroughly understand the mechanical principles that regulate movement. The analysis of human movement and sport movement using the principles of physics and mechanics is called biomechanics. In recent years, the study of biomechanics has grown tremendously in the United States, and it is commonly recognized as a discipline of physical education, exercise science, and sport. Biomechanics is concerned with two major areas of study. The first area focuses on the anatomical aspects of movement, while the second concerns itself with the mechanical aspects of movement. Needless to say, these areas are closely related. The terms power, acceleration, velocity, mass, pressure, friction, work, energy, angular velocity, acceleration, torque, and gravity are all defined in this chapter. There are selected biomechanical principles and concepts pertaining to stability, motion, leverage, and force that we talked about today. And within the last 15 years, improvements in instrumentation and its application have been numerous, which has greatly expanded the knowledge base. Although the practitioner may not have access to much of the specialized equipment used by biomechanists researchers, the practitioner can use available technology such as video, wearable technology, mobile apps, or just direct observation to analyze performance. Understanding the principles of biomechanics is essential in improving individuals' performance. Hey, I thank you for talking with me today. We're going to be transitioning into Chapter 7, and I will talk with you more another day. Have a great day.